Here's integrated 3. It's problem 3-7. We were doing this in class. It says, consider each of the following equations. What structure can you see that might help you rewrite the equation as Graciela did? And 3-6, remember she wrote these boxes. Indicate what your box or repeated piece is. Be ready to share your ideas on rewriting with the class. You do not need to actually solve these equations. So I'm going to go ahead and call this what it is. This is called, in calculus, this is called U substitution, and they're teaching it to you already, even though you're in integrated 3. So we're going to, like, instead of making a box like Graciela did, we're going to choose a letter to stand for this repeated factor here. Let's use the letter U. So for this whole thing, I can substitute in the letter U. And for this thing, we said U is equal to it, so. And then I can bring the 6 over to the other side. And I may or may not be able to factor that. Okay? So I'm not going to solve it, but I could either factor that. I don't know, we could try. Those are the letter U. I know they look like 4s, I'm sorry. So I can say that U is equal to 3, or U is equal to -2. You can see why I don't like to do a U substitution, because the letter U, I would prefer to use a different letter. And then I would have to finish this problem now, I would have to plug the 3 in for U right here. And so then I would end up having to subtract it from both sides, and I'd have to factor this quadratic. And then I'd have to go back and also substitute in -2 right there for U. And then I would have to add that 2 on both sides. It turns out that you can't factor over here, and you end up having to do a quadratic formula problem. But you can see that that would be easier than the alternative. The alternative would be to square this whole darn thing out, which would mean you'd have to make like a 3-way like area model that was like this. And you'd get all these terms just to square that out. And then you'd have to combine all the like terms, and you'd have to boil it down to a quadratic, and it would take probably a whole page to do all that. So this really is a shortcut, even it might not seem like it. But we don't have to solve them. We're just trying to use the structure to set up a U substitution, or an advanced kind of substitution. Usually this will involve factoring. So now this, I don't really want to try to factor that. I'm going to let A equal x to the 1/3. How did I know what I wanted my box or whatever to equal? I usually look, I'll just give you a hint, I always look at the middle term, because watch, if I just take this term here and set it equal to A, that means I can plug an A in for it. But over here, that's not 1/3, that's 2/3. But I can still plug my A in. I can. Why is that? Because 1/3 squared is actually 2/3. I don't know if you can realize that. 1/3 squared, you just multiply the 2 times the 1, and it's 2/3. And then I can take this, and I'm not going to solve the whole thing, but I would be able to try to do a diamond problem on it. So this could be factored as A plus 7 and A minus 8. And then I could say A equals -7 or A equals 8. And then I wouldn't be done yet, because I would have to plug, remember over here I said that A was equal to x to the 3rd, or x to the 1/3. So I would have to set -7 equal x to to equal x to the 1/3, and then I would probably have to cube both sides to get that 1/3 to go away. And I don't know if you even know about how to do those kinds of things yet, but I just want you to know that this is called a U substitution, even though I use the letter A. I'll use U again over here, but it's just an advanced algebra technique. This one would be a great quadratic to solve if it were a quadratic, but it's not. It's got something to the 6th and something to the 3rd. So I look at my middle term, which is y to the 3rd, and that's what I'm going to set my u equal to. This time I'm just going to make my u like a big uppercase U so it doesn't look like a 4. Okay, every time I see a y cubed, I'm going to put a u in, even though I only see one right now. That's going to be a u. Don't worry, it's going to be okay. I'm going to put a u over here because I know somehow one's going to end up there. Isn't this, if I had y cubed and then I squared it, wouldn't that be y to the 6th? So this is actually u squared, and I hope that you're starting to get the idea that now I can do a diamond problem on this. U plus 6, u minus 3. So u equals -6, u equals 3. Now, I don't really want to solve it, but if I did want to solve it, I would take both of these u's and I would plug them one at a time in here. Like I would say -6 is equal to y to the cubed. And then I would probably have to cube root both sides to find out what y is. And same thing here, I'd have to put 3 is equal to y cubed, and I'd have to cube root both sides. And I'd get some yucky answer, but we don't have to solve these. Now this one's interesting. This, I don't know if you can see it. This is a square root sign right here. But I'm going to take this, and I'm going to go ahead and let it be my u. U is equal to square root p. So I've got -12 u. I'm going to bring the 35 to the other side. But what about this? Well, isn't square root p squared? Wouldn't that give me p? So if u is square root p, then u squared is p. So I'm going to write my u squared here. And then if I want to, I can do a diamond problem. I don't know, 35. 7 times 5, 35. So I could say that's u minus 7 and u minus 5. So u equals 7 and u equals 5. And then I'm not done yet. I would have to plug those in over here. And so then I would say 7 equals square root p, and I'd probably have to square both sides. P would be 49. And then I would have to say 5 equals square root p, and I guess that would make p equal 25. So I'm not solving these, though. I'm just showing you how to set them up. And finally, the last one, I think I would choose this one as my u right here. So I would say u, because see, they have these like matching, they're not really factors, but there's these matching pairs, I guess you could say. So let's let u equal the square root of x plus 1/4. So that way, this would just be written as 3u equals 9u squared. And And then I could solve that if I want to, because I could turn the 9 into a 3 squared, and then I would have, you probably don't know how to do this yet. I'd have 3u equals, if 3 squared is 9, I'd have 3 squared times u times 2. That would equal 3u here. And the 2 times 2 is 4. 4u. And then I could just equate these exponents. I'd say u equals 4u. And then, I don't know, I guess I would subtract u on both sides. And I'll say, I shouldn't have tried to solve this one. Well, 0 equals 3u. So u would be 0. 3 to the 0 equals 9 to the 0. Right? I don't know. We're not supposed to solve them anyway, but I hope that you get the idea that there's this thing called u substitutions. They don't tell you that's what it's called, but they're going to call it Graciella's method. Okay, and you might have to do this sometimes.